Whoopsie. Sorry, I started my recording a little bit late. You didn't miss too much though. All right. Okay. So let's see here. All right. Okay, so I'll go ahead and give you a question on learning catalytics. And the question on learning catalytics right now is parentheses, -4, close parentheses, squared. All right, so go ahead and try that one on your own and see what you get for your answer. And I'd encourage you to try to do it without a calculator. These calculators don't always help you in all situations. So, you know, like when you're doing algebra and you have variables and stuff, you know, those variables don't really go into the calculator very well. So it's important to understand these principles and how to do it without a calculator. All right, here we go. So that's saying -4 times -4. And so that would equal +16. Okay, here's another one on learning catalytics. This one is like so. So go ahead and try that on your own, see what you get. All right, and so since it doesn't have the parentheses, then it's like that. And so 2 to the 6th power is 64. And so this would be -64. All right. Here's another one on learning catalytics for you. And it is like so. Try that one. Okay, so in this case, it's a -2 to the 3rd power. So that 3 is an odd number. So if you have a negative raised to an odd power, the answer is still going to be negative because you're doing -2 times -2 times -2. And so -2 times -2 would equal +4. And then that +4 is going to be multiplied by -2. So that's going to end up giving you -8 for your answer. All right. Let me know if you have any questions. All right. Let's look at the exponent rules. All right. Okay. So right here, I'm just showing the terminology. So the exponents, also known as the powers, so those are the little superscripts up here. Those are the exponents. And then whatever the exponent is applied to is the base. And then you can also have a numerical coefficient in front of, you know, like if you have variables here and then you have a numerical coefficient here. All right, so that's just the terminology for you. And then here are the rules. Okay. And again, I'm thinking that you guys have seen these rules before. If you're multiplying two things with the same base, you add the exponents. If you're dividing two things with the same base, you subtract the exponents. If you have something with an exponent and then raised to another exponent, you would multiply the exponents. Okay, those ones seem to be pretty easy to remember. If you have an exponent on the outside of the parentheses, if the thing that's inside the parentheses is one term, meaning that they're just multiplying or they're just dividing, then you can distribute that exponent. Okay. Let's see. And then anything raised to a power of 0 always equals 1. And then here's the rule that has to do with the negative exponents. So like x to the negative n is the same thing as 1 over x to the n. And again, that's a really important one that I feel like a lot of people struggle with. Let me see here. So I think I want to do a little additional explanation for you guys that I don't necessarily always do in my regular classes, but I think it would be really helpful. I want to show you kind of an explanation of why these rules are true and why they work. In a way, these rules, we call them rules, but they're kind of just like shortcuts. You can think of it as a shortcut, actually. Okay, and I'll show you why. All right, so I'll start with this first rule. So let's say that I have x squared multiplied by x to the third power. Okay, well, I know that x squared is the same thing as x times x. And I know that x to the third power, which is also sometimes called x cubed, I know that's the same thing as x times x times x. Okay, so all I did was I just wrote them out long ways instead of using the exponent. So now I see that I have x times x times x times x times x. So we know that that would equal x to the fifth power. Okay, so that's kind of just the long way of doing it. And then the shortcut way of doing it would be just to add the exponents. All right, so that's why that rule works. So that's rule number 1. And then rule number 2, okay, let's do an example on that one. So let's say we have x to the 6th power over x squared, let's say. Okay, well, again, I can write those exponents out. So x to the 6th, 1, 2, 3, 4, 5, 6. So x times x times x times x times x times x. All right, over x squared, and if I write that out, it's just x times x. Okay, and then I know that I can cancel out, and those x's, and I can cancel out those x's. And now what I have left is x times x times x times x, or in other words, I could just call that x to the 4th power for my final answer. Or as a shortcut, I could have just subtracted those. Okay. All right. Let's see. And rule number 3. All right, so let's say we have x to the 3rd power, and then let's say that whole thing is squared, or raised to the second power. All right, so x to the third squared. So that means the same thing as x to the third times x to the third, right? And then if we go ahead and use what we already talked about in rule number 1, we know we could just add those exponents. 3 plus 3 is 6. So we could just say that's x to the 6th power. X to the 6th power. Okay. So there you have it. So again, that's another shortcut. So this one kind of built on top of number 1. All right, so because, whenever you are multiplying is really just another way of repeated addition, right? Okay, let's see. Okay, so let's talk about rule number 5, which I have here. X to the 0 power is equal to 1. So that might seem kind of random, but it's not. And I'll show you why. All right, well, let's say that we have x to the third power over x to the third power. Okay, well, if we use rule number 2 that we already talked about, that tells us that we can subtract the exponents, we could do that here. 3 minus 3 is equal to 0, right? So that would be the same thing as x to the power of 0, right? Okay, well, if we look at that same problem another way, x to the third power over x to the third power, well, we know that anything divided by itself is always equal to 1. How many times will x cubed go into x cubed? Well, of course, that's going to be 1. All right, so if x cubed over x cubed equals x to the power of 0, and x cubed over x cubed also equals 1, then it must also be true that x to the power of 0 equals 1. I think that's pretty cool, but of course I'm a math nerd, so that's me. All right, so just to let you know that these rules are not just something that some nerdy math person like me just randomly made up, to annoy you or anything like that. They're really true for a reason. And then let's look at the last one, and this has to do with negatives, which, like I said, I know that's something that people have a lot of issues with. This one, it's a really important one going forward. When you go into pre-cal and then when you go into calculus, you're going to have to use this rule a lot. So it's really important to understand. Okay, so rule number 7. All right, so let's say that we have x to the power of 2 over x to the power of 5. Okay, and we've already talked about, we know that we could take a shortcut by subtracting those exponents. So 2 minus 5, we know that would equal -3. So that would be x to the power of -3. All right, but what if we take that same problem and we write it out the way that we did earlier? So on the top, we write out x times x, and on the bottom, we write out x times x times x times x times x. 1, 2, 3, and 5. Okay. All right. So then we could basically cancel those out. We could cancel those out. Okay. So in this case, then we have x times x times x on the denominator. That's x to the third power on the denominator. Okay. So then we still need to have the 1 on the numerator. So technically, when we're canceling these out, we're saying like, okay, well, x goes into x one time, and x goes into x one time. So we do need that 1. So again, here we see that x to the power of -3 is the same thing as 1 over x cubed. So those are two different ways of writing the answer. And so if this equals x cubed, x to the -3, and this same thing also equals 1 over x cubed, then it must be that these two things are equal to each other. Okay, so typically in algebra, we want to write things without using negative exponents. So we'll give our answer in this form. All right, but when you go, when you're going into pre-cal and calculus, it's going to be a lot, you're going to have a lot of problems where you'll start out with something that looks like this, and you'll want to actually write it in this form using the negative exponent so that you can then do derivatives, which is calculus stuff. All right. All right. So hopefully that's helpful for you guys there. Just let me know again if you have any questions. So, all right, so I spent quite a bit of time going over that explanation. So I will definitely not do all of these examples that I have on these notes, but I'll do some. Let's see. All right, so let's look at this one right here. So we have 3x to the power of 0 versus 3x in parentheses to the power of 0. So with the parentheses, it's showing that that exponent applies to that whole thing that's in parentheses. So the answer for part B is just 1, because 3x to the 0, so everything is raised to the power of 0. So that just equals 1. All right, but without the parentheses, then we know that it's only the x that the 0 exponent applies to. So like this part turns into 1, and it's like 3 times 1, which is 3. So that answer is going to be 3. Okay, and number 6, a to the power of 8 times a to the power of 12. So we just add the exponents. 8 plus 12 is 20. So that would be a to the power of 20. All right. I'll just do maybe a couple of these. Let's see. Let's do number 8. So in that case, we have -4 times -3. So those are the numerical coefficients. We want to multiply those together. So -4 times -3 is +12. And then we have x squared times x. So x is the same thing as x to the power of 1. So there's an invisible exponent of 1 there. And so so you add the exponents, 2 plus 1 would be 3. So that'll be x to the 3rd power. All right. Oh, let's see. Let's move down here where we have some negatives, because like I said, that's something I want to really focus on. Y to the -5, if we want to write that without the negative in the exponent, that would be the same thing as 1 over y to the 5th power. All right. And then, like I said, you want to be able to recognize if you see 1 over y to the 5th power, it's also good to be able to write that in the form of y to the power of -5 as well. All right. Number 14, 1 over z to the negative 10. So since the negative exponent is already in the denominator, I want to move that up to the numerator. So when you have that negative exponent, it's basically the same thing as like doing a reciprocal, okay? So this is going to actually turn into z to the power of positive 10. All right, and on number 15, all those exponents are negative. So if we want to get rid of all those negatives in the exponent, we're just going to flip it over, and that'll get rid of all the negatives. So it'll be z to the 5. I'm in my grandpa's office today, so we're getting motorcycle sounds again at 4 p.m. on the dot. All right, so that's z to the 5 over x to the 6 y squared. So just flip it over, and that got rid of all the negatives. All right, number 16, a to the 5, b to the negative 8. So that would be the same thing as a to the 5 over b to the positive 8. All right, and let's see, number 17. I don't have it enough. That other problem is in the way, but that's okay. I don't really need that. All right, let's see. So here we have a negative exponent on the outside of the parentheses. So probably the first thing I would do is take care of that negative. So that's going to make it 1 over, okay? And then the denominator is basically going to be exactly the same as this. The only difference is that 2 will be positive instead of negative. So it'll be parentheses. So the stuff that's in the parentheses stays exactly the same. 4x to the negative 4, and then all that is squared. All right, and then I'll go ahead and distribute that exponent. So it's 1 over, and then 4 squared is 16. And then I would multiply those exponents. So negative 4 times 2 is negative 8. So now I have 1 over 16x to the negative 8. So now to get rid of that negative exponent, I will take the x part that has the negative exponent on it and move it up here, and that'll get rid of that negative. So that's going to turn it into x to the power of positive 8 over 16. And that's my answer for that one. All righty. Let's see. Number 18, 4 to the negative 1 plus 5 to the negative 1. So that's basically just saying 1/4 plus 1/5. So then we could add those. So I would just use the bow tie method to add those. So 1 times 5 is 5. 1 times 4 is 4. So 5 plus 4 on the numerator. And then multiply straight across the bottom. 4 times 5 is 20. So then 5 plus 4 is 9. So 9 over 20 is the answer for that one. All right, and then here we have negative 3 to the power of negative 2 with parentheses versus without parentheses. All right, so I'll go ahead and take care of that negative exponent first. So if I want to get rid of the negative in the exponent, that's going to make it 1 over parentheses negative 3 squared. Okay, so it's 1 over this whole thing, but the only thing that's different is the 2. The exponent of 2 became positive instead of negative. So then that would be negative 3 times negative 3, that would be positive 9. So a positive 1/9 would be the answer for that one. Now, if we do basically the same exact thing, only without the parentheses, I'm going to add in my own parentheses like this. That's what it means. All right, so that negative is out front. It's like separate. All right, and then 3 to the power of negative 2 would just be the same as 1 over 3 squared. And then I know that 3 squared is 9. So this would be negative 1/9. Okay, let's see. So number 21 is just subtracting the exponents. 13 minus 3 is 10, so that's x to the 10. Number 22, it's pretty much the same thing. 16 minus 13 is 3, so that's going to be b to the third power, and then that 5 is just going to stay there on the denominator. So b cubed over 5 is the answer for that one. And then on number 23, 20 minus 23 is negative 3. So you could say that's b to the negative 3. Or if you don't want to have a negative exponent, you can think of it as, okay, so I've got the larger exponent on the denominator, and so I know that's where my b is ultimately going to end up. And then 23 minus 20 is 3. So it's just 1 over b cubed. All right, so I think when you're doing your homework, typically they're going to want your answer without negative exponents. Number 24 can't be simplified because those are not like bases, so you can't simplify that. Number 26, we have a couple of negative exponents there. So one thing we could do is you could go ahead and just flip the whole thing, and that will get rid of both of the negatives. So that would make it p squared over p to the fifth. And then that's going to end up as 1 over p cubed. All right, let's see. Let's go to number 28. Distribute that exponent. That's going to be a squared. And then 4 times 2 is 8, so it'll be b to the 8th power. Let's go to number 31. All right, so don't forget you have to distribute that exponent to the numerical coefficient as well. So it's like you have negative 2 to the 4th power. So that's a negative raised to an even exponent, so it's going to end up being positive. And we know that 2 to the 4th power is 16, so that's going to be 16. And then 5 times 4 is 20, so it'll be a to the power of 20. Okay, let's see. Let's do number 35 right here. So negative. So that negative is going to stay there. It's still going to be negative, and you can put it in front of the numerator or you can put it in front of the whole fraction. Either way, it doesn't matter. Let's see. So 36 would actually go into 72 exactly 2 times. So we're going to have that 2 in the denominator. All right, and then the x has a larger exponent on the denominator, so the x is going to stay in the denominator. And I know that 5 minus 2 is 3, so it's going to be x squared in the denominator. And then the y has the higher exponent on the numerator, so y is going to be in the numerator. And y is the same thing as y to the power of 1. So there's an invisible 1 there, and then 7 minus 1 is 6. So we have negative y to the 6 over 2x squared. Okay. Let's go down to number 38. We've got some negative exponents there. So we have the negative exponent on the outside, so I would take care of that first. So it would just end up being 1 over, and it's going to be exactly that, except for the 3 is going to be positive. So it would be parentheses, 4x squared, y to the 4th, close the parentheses, raised to the third power, and then it's still going to be 1 over all of this. And then again, don't forget to do the numerical coefficient raised to the exponent as well. So 4 to the third power is going to be 64. And then 2 times 3 is 6, so it's going to be x to the 6. And 4 times 3 is 12, so it's going to be y to the 12. All right. And number 39, I'm going to take the ones that have the negative exponents, and then they need to be moved to the other side of the fraction bar. That 4 is going to stay there, but both of those are going to go down to the denominator. So it's going to be x squared, y to the third, and then I still have that y to the fourth right there in the denominator. So I need to go ahead and combine the y's on the denominator. So it's still going to be 4 over x squared, and then 3 plus 4 is going to be 7, so it's y to the 7. So 4 over x squared, y to the 7. All right, number 40, both of those. So in this case, the stuff that's in the parentheses is the same on the top and the bottom. So we can treat that as like bases. Both of these exponents are negative, so we could just go ahead and flip it over, and that'll get rid of both of those negatives. So it'll be parentheses 2ab squared to the fourth over parentheses 2ab squared to the third. Then, like I said, just treat this as like bases. So just go ahead and subtract 4 minus 3 is going to be 1. So it's just going to be parentheses 2ab squared to the power of 1. Or in other words, it's just 2ab squared. All right. Number 41, just take the ones that have negative exponents and move them down to the denominator. So z to the third is going to be on the numerator. And then on the denominator, you're going to have x to the fifth y squared. So z cubed over x to the fifth y squared. Number 42, I have a fraction that's raised to a negative exponent. So I would go ahead and flip that whole fraction over, and that'll make that negative exponent turn into a positive. So in the numerator, it would be c squared, and then that would be over 2a cubed b to the 0. All that's now raised to the power of positive 3. And then we know that b to the 0, of course, is just 1. And so if you're just multiplying or dividing by a 1, that doesn't do anything. So basically just cancel that out. And then 2 times 3 is 6. So that's going to be c to the 6 over. And then this 2 has to be raised to the third power. So 2 to the third power is 8. And then 3 times 3 is 9, so a to the power of 9. So c to the 6 over 8a to the power of 9. This problem got cut off by my printer. Okay, so on this one, I guess there's different ways you can go about it, but let's just kind of just do it straight up and say negative 6 minus negative 2. So a to the power of negative 6 minus negative 2. And then we have b to the power of 3 minus negative 5. So minus a negative turns into plus. So that turns into plus, and that turns into plus. All right, so negative 6 plus 2 is going to equal negative 4. So a to the power of negative 4. And then 3 plus 5 is 8, so that's b to the 8. And then we can take the one that has the negative exponent and move it to the denominator. So it's going to end up being b to the 8 over a to the 4. All right. Any questions about anything? All right. Well, thanks for being here and look forward to seeing you next time. Email me if you have any questions. Thank you. Bye. Have a good weekend.
You too.